Good morning, students. Myself, Vijay Shankar from EC department, Chevrolet Engineering College. So today we are going to discuss about the BCD 7-segment decoder and comparators. In yesterday class also, we completed some part of the BCD 7-segment decoder. That is nothing but a binary coded decimal 7-segment decoder. In this, the designing of the BCD 7-segment decoder, the first K map is completed, and remaining the K maps you can see in this session. You see the BCD 7-segment decoder. The first K map is completed. For the second K map here, that to get the B Boolean expression, we having 0, 1, 2, 3, 4, 7, 8, 9. Okay, and the remaining are the don't gets. See one 8-box combination here. For this 8-box combination, A0 and A1 is the values is 1, and we have only the A3 and A2. In that, A3 is 0 and A2 is a 0 here, and 1 0. A3 is changes from 0 to 1. We'll get the A2. A2 is a 0 means A2 bar. Okay. For another 4-box combination here, the 4-box combination, the first vertical 4-box combination, A3, A2 is a 1, and we have A1 bar and A0 bar. A1 bar, these values A1 bar, my dear students. Not the A1, it is A1 bar, A0 bar. A1 bar and A0 bar. And next 4-box combination we have, that is A0 and A1. Okay. In this Boolean expression, it is not the A1. The second term is A1 bar, A0 bar, A2 bar plus A1, A0. Okay. And coming to the third, to get the C Boolean expression, what are the min terms here? The C is equal to 0, 1, 3, 4, 0, 1, 3, 4, okay, and 5, 6, 7, 8, 9. 0, 1, 3, 4, 5, 6, 7, 8, 9. All it is a 4-box, the remaining or it is a 10 to 15 is a don't cares. So here there is a 4-box combination they used, it is wrong. I will show that in the next slide. You can see here. I'm taking the one K map. Let it be. They are naming as A3, A2, A1, A0. A3, A2, A1, A0. The min terms are 0, 1, 3, 4, 5, 3, 4, 5, 6 up to the 9. 0, 1. So A1, A0 in the horizontally, and A3, A2 on the MSB bits. These two are. So 0, 0, 0, 1, 1, 1, and 1, 0. And here also the 0, 0, 0, 1, 1, 1, and 1, 0. So 0, 1, 2, 3, 4, 5, 7, 8, 4, 5, 6, 7. 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay. So 0 is one of the min term. 0, 1. So 0, 1, 3 to 9. 3, 4, 5, 6, 7, 8, 9. Okay. 0, 1, 3, 4, 5, 6, 7, 8, 9. These are the min terms we have. and the don't care is the remaining of the don't case only. The remaining don't case, you can see this is a don't care, and here it is a don't care, all from 10 to 15. So first of all, you can see the minterms is covered or not. I'm taking for these as one 8-box combination. So 0, 1, 4, 5, 8, 9 is covered, and another 8-box combination will get like this. Okay, and finally to get it is 3, another 8-box combination like this. So totally 3 8-box combinations to cover all the minterms. The function is the function of A3, A2, A1 and A0 is equal to. For the first 4 8-box combination, you can see here this is the first 4 8-box combination I taken. It is a vertically A3, A2 is a 1 and A1 bar plus another 8-box combination vertically we have it is A3 and A2 is a 1 and A0 is a value is 1. A1 bar is changes, A1 is changes to 0 to 1 and A0 value is a 1. So A0 plus, and this is another 8-box combination we have. A0, A1 is becomes value 1 and the A3 is changes from 0 to 1 and A2 is a 1. A2 is 1 means A2. So for C is equal to whatever the C is A1 bar A0 plus A2. Actually what we here, the C whatever they are saying, it is the wrong. It is not the 2-box combination. If it having with other combinations is there, with the 8-box combination, you can take that 8-box combination, the first 8-box combination and second 8-box combination and third 8-box combination. And also here also you can observe there, when I'm using this one, so no need of this one, no need of the second one, whatever you have, the God it's a A2, no need of this also. Why I'm saying this, when this first vertical 8-box combination 8, 9, 1, 4, 1, 4, 5, 0 is covered, and this for 8-box combination the 3 is also covered, 3 and 7, but here the 6 is there. For that 6 only we getting. Yeah, but in the material they taken the 3 and 7 and 1, 4, 5, 0 is a 2-box combination. Whenever there is another with the don't case, you can go for the maximum box combination only. Maximum box combination. Don't go for that is a minimum box combination. If there is any maximum box combination with the don't case, you go for the maximum box combination only. Don't go for the minimum box combination. Whatever the material we have, the C is equal to, it is a wrong. It having the 3 8-box combination, having the 3 terms with 1 literal order. Following my dear students. Next one is for D is wrong. The C is equal to, because there is a 1 8-box combination here, another 8-box combination, another 8-box combination, including with the don't case. And for to get the D, you see the minterms 0, 2, 3, 5, 6, 8, 9. 0, 2, 3, 5, 6, 8, 9. Using that, go for another one. Take the 4 variable K-map. So A1, A0, and A3, A2. So 0, 1, 3, 2, 4, 5, 7, 6, 8, 9, 10, 11, 12, 13, 15, and 14. Okay. This value is a 0, 0, 0, 1, 1, 1, 1, 0, and 0, 0, 0, 1, 1, 1, and 1, 0. So see what are the min terms we have. The min terms are for D 0, 2, 3, 5, 6, 8, 9. 0, 2, 3, 5, 6, 8, 9. And remaining are the don't case. Okay. Remaining are the don't case. Just to avoid the confusion, I'm taking here is a min terms is another color. The one min term 0, 2, 3, 5, 6, and 8, 9. Now, first of all, see that the min terms are covered or not. So, what are the min terms here? If I'm taking the 1 8 box combination like this, it covers end 8, 9. And to cover 0, 2, 10, and 8. That is a another 4 box combination. And remaining is a 3, 6, and 5. Suppose if you take the 5, suppose you can take the 5 here. So 5 with there is no any 4 box combination because there is no 7 here. 5 with 13 you can take as a 2 box combination only. 5 with 13 2 box combination. And remaining here it is a 3 and 6. 3 and 6. If we convert this 6 as a 4 box combination here, the 4 box combination with the don't case. 4 box combination with the don't case. Still there is a another is remain, it is a 3. So for that 3, you go for 1 and 2. 11 and 10 is a 4 box combination. 11 and 10 is a 4 box combination. So how many 4 box combinations here? The 2 4 box combinations, 1 8 box combination, and 1 2 box combination we got. So for the D is equal to is a function of the MSB bits are A3, A2, and A1, A0 are the LSB bits. Is equal to the first, if I am writing that it is a 8 box combination. That 8 box combination, you can see the A1 and A0 is the 1s, and we have the A2 is changes from 1 to 0, and A3 is the 1. So you get only the A3 plus the 4 box combination of the corner bits. The corner bits you can see A1 and A0. In this A1 is changes from 0 to 1. A0 is there, so A0 bar because it's a 0. A0 bar. And these two, the A3 and A2 MSB bits, A2 is there, A2 bar. A3 is changes from 1 to 0. We got the 4 box combination. We will get the 2 literals. 8 box combination means 1 literal only. Another 4 box combination we have, that is a 3, 2, and 10, 11 with don't cares. So correspondingly, you can see the A1 is 1. So A1. And here 0, 0, 0, 1, 1, 0. So A2 bar. A2 bar. Okay. The 2 box combination here, that is 2 box combination plus A2, A1 bar, and A0. So correspondingly for these 2 box combination, you can see the A3 is changes and A2 is a 1, so A2, and A1 is a 0, A1 bar, and A0 is a 1, A0. So we'll get the totally 4 terms, A3 plus A0 bar and A2 bar plus A1, A2 bar, and A2, A1, A0. Actually, you have to write it is in the order. A3 is MSB bit, put it here, and A2 bar is a MSB, and A0 bar is order actually, plus A2 bar and A1 plus A2, A1 bar and A0. So these are the values. So see in the material, if any wrong is there, to get it is a D. D is equal to A3 is there. We got the A3 and A2 bar A1, A3, A2 bar A1. We got this one and this two, the two terms. And second one, A2 A1 bar A0, A2 A1 bar A0. This also we got this one. And another one is an A2 bar and A0 bar. A2 bar and A0 bar. A2 bar and A0 bar. There is no any this term. So why we got this term means they taken is a two box combinations. Here, no, don't take this as a two box combination, 6 and 4. So 8 box combination is right, and corner bits of the 2 box combination is also right, and the 4 box combination of 3, 2 and the 10, 11 is also right. But for to cover the 6, don't take the 6 and 4. You take the 2, 6, 4 and the 10. Not the 4, it's a 14. 2, 6, 14 and the 10. Total the 4 box combination. Okay. Then only it is the right answer. So no need of this one. We have only the A3, A2 bar A1 plus A2, A1 bar A0 plus A2 bar and A0 bar. A2 bar and A0 bar. No need of the another 2 box combination there. Following my students. Then after. To get the E K map 0 to 68. See the 0 to 68. Take another K map here. 0 to 68. Zero here. 0, 2, 4, 5, 6, and 8. These are values actually. A1, A0, and A3, A2. Follow my students. We have only the 4 min terms for E. E is 0 to 68. 0 to 68, and the remaining all the don't case one. So I'm using the don't case here. It is 10, 11, 12, 13, 14, 15, and the 15. Now, first of all, you can cover the min terms only. Now I'm taking these min terms here as a 4 box combination, and for the 6, another 4 box combination. Okay, and this value is a 0, 0, 0, 1, 1, 1, and 1, 0. And this value is a 0, 0, 0, 1, 1, 1, and 1, 0. Okay. For corner bits, for E is equal to, for corner bits, you can see the A0 bar and A2 bar. So A2 bar and the A0 bar. So 1 4 box combination. We'll get only the 2 literals. Another 4 box combination is there. Vertically, we have A2 and A3 is a 1, and A1 is 1, and A0 is a 0. So A1, A0 bar is the equation for the E. Let us see whatever the material, it is a right or wrong. E is equal to A1, A0 bar, A1, A0 bar, A1 and A0 bar. It is right. We got the same answer, same term. And second term is A2 bar and A0 bar. A2 bar and A0 bar. A2 bar and the A0 bar. Whatever the E is the right answer. See, observe here. In the previous example also, the previous to find the D function also, the 6 is there. They use the 2 box combination here. Don't use the 2 box combination. If any maximum box combination with including the don't case, you go for the maximum box combination. Don't go for the minimum box combination, my dear students. So E is whatever it is the right answer. But D there is no any term this one. Only we have the A3 plus A2 bar A1 plus A2 A1 bar A0 plus A2 bar and the A0 bar. There is no any another two box combination equation here. Last is F and the Z. See the F. What are the minterms for the F here? See the minterms is 0, 4, 0, 4, 5, 6, 8, 9. 0, 4, 5, 6, 8, 9. 0, 4, 5, 6, 8, 9. See here also, to cover the 8 and 9, they use the 8 box combination. Is it okay? 8, 9 is covered. And coming to the 0, 4, 5, 6 is remaining. So to cover the 0, you go for the 4 box combination, it is also okay. And the 5 is remaining and the 6 is remaining. 5 and 6 is the remaining, my dear students. So for the 5, don't go for the 2 box combination here. It is a 4 box combination is there. The 4 box combination including with the don't case of 13 and 12. And for 6 and 14 also, don't go for the 2 box combination here. There is a 4 box combination for 6, 14 and the 4, 12. So use the 4 box combinations. Go for always a maximum box combination to reduce the minimum number of literals in the Boolean function. Okay, 1 8 box combination and 3 4 box combinations will get 3 4 box combinations. So what is the 3 4 box combinations? What are the 8 box combination here we got? That is the right answer. For that, what is the term? We'll get A1 and A0 is a 1. And we have here the A3 and A2 only. A2 is changes from 0 to 1. And A3. So A3, whatever the second term is the right answer. And for this one, the 4 box combination here, A1 bar and A0. The first 2 terms is whatever it is correct. And let us see the third and the fourth terms. Third and fourth terms, it is not the 3 literals, it will get only the 2 literals only. Okay. See the 4 box combination. If I am taking the 4 box combination of 5, 4, 12, 13, 5, 4, 12, 13, you can see here A2, A1 bar, A2, A1 bar, A2, A1 bar. Don't use this A3 here, A3 bar, A3 bar. Why we got this A3 bar? Whenever you go for the 4 and 5, the 2 box combination, A3 bar, A2 and A1 bar will get. If you go the 4 box combination here, A2 and A1 bar only will get. So 1 literal it reduces. Okay, there is no any A3 here in the third term, A3. It is only the A2 and A1 bar. And coming the last term also, don't use the 2 box combination here. The 6, 14 and 4, 12 is a 4 box combination. We have adjacent sides, including the don't case. So for that, A2 and A0 bar. There is no any A1. A2 and A0 bar. There is no any A1 here. Don't use this A1 and don't use the A3 bar here. All my dear students. And the last one, you can see the G Boolean expression. For the G Boolean expression, 2, 3, 4, 5, 6, 8, 9. 2, 3, 4, 5, 6, 8, 9. Now, again, 8, 9 is covered for the 8 box combination. And you can see the 5, 4 is remaining. That 5, 4 is covered with 4 box combination. See here. Here they use the 5, 4, 12, 30 is a 4 box combination. But here they are using the 5, 4, it is a 2 box combination. It's wrong. Okay. So it is always go for the maximum box combination. The 5, 4, 12 and 13 is a 4 box combination. And even after this 8 box combination and the 4 box combination, 8, 9, 4, 5 is only the covered. 6, 12, 6, 2, 3. 2, 3, 6 is not covered. Okay. To cover the 2, 3, use the 4 box combination here with the 2, 3 and 10, 11. So still it is a 1 is remaining, 6 is remaining. You can go for 4, 12, 6, 14. That is a one way. Or otherwise, the vertical combination we have. We get the 2 options to cover the min term of 6. Following. So for 8-box combination, what is the value? We'll get A3. That is the first term in the Z. That is the first term in the Z here, A3. And for this 4-box combination, A2, A1 bar, A2, A1 bar, that is the third term. And for this 4-box combination, correspondingly you can see 0, 0, 1, 0, A2 bar, A1. A2 bar, A1, that is the fourth term. And for this vertical for 4-box combination, A1, A0 bar, A1, A0 bar. So whatever the G is, the material is right, my dear students. You can change it. What will there the mistakes in the material? It is a GF is having some changes there, and the D is also some change. And here the C is also change is there. And here the A is also some change, because they are using only the minimum box combination. If they are having a maximum box combination also, they go for the minimum box combination. Don't go for like that. Okay. So by using that Boolean functions, whatever we got A, B, C, D, E, F, and the G, you can draw a logical diagram to get it is a 7-segment display. This total logical diagram is in the inside of the 7-segment. Whatever we drawn that block diagram. See, this is a block diagram. Inside there is a logical diagram what we design here. This is a logical diagram A, B, C, D with the inputs of A1, A0, A2, and A3. A1, A2, and A3, my dear students. In this block diagram, inside there is a logical diagram with the inputs of A0, A1, A2, A3, and the outputs of A to G according to the given inputs 0, 0, 0, 2. Then it displays a 0, 1, 2, and up to so on the 9 values. To display the 10, it requires another 7-segment. So 1 digit and the 2 digits. It requires the 2 digits. It requires the 2 7-segment decoders. And then if you need, it is a 3 means 3 7-segment decoders. The above of 99. That is nothing but 100. The decimal value I'm saying, not the 100 is not, don't take it as a binary, it is 100. The 3 digits means you go for the 3 BCD 7-segment decoders. Here we are using only the 1 7-segment decoder. It can get only from 0 to 9 values only, the BCD. From 10, it requires another BCD 7-segment decoder. Following, my dear students. Then you go for the next topic, that is comparator. Comparator. So comparator, the name itself, it is a comparing. Always a comparison between the two more than the 2. Not the single. If there is any single, there is no any comparison. When the comparison occurs, when there is a 2 more than the 2, there is a comparison occurs. So what is a comparison? Always you can see that comparison is always either those 2 are equal or less than from one to another or greater than from one to another. These are only the comparisons we have: equal, less, and the greater. The comparator is also a combination circuit. It compares the magnitude of 2 n bits. A having the n number of bits is there, and B having also n number of bits. Comparing between A and B only. Okay, comparing between A and B. If any number of bits are there in the A, and if any number of bits are there in the B, you can compare the magnitude of 2 n bit numbers and provides the relative result as the output. The block diagram of n bit digital comparator has 2 inputs and 3 inputs. A and B are the n number of inputs. Means the minimum it having the 2 inputs and the 3 outputs. The 3 outputs are A and B are the n bits. The comparator outputs are A greater than B, A equal to B, and A less than B. Okay, minimum of 2 inputs, and the outputs is always a 3. That is a less than, greater than, and the equal condition. Depending upon the result, the comparison, one of these outputs will be high. Depending upon the comparison between of A and B. If A is less than the B, A less than B is high, and A equal to B, A greater than B is a 0. If A equal to B, A less than B is a 0, A equal to B is equal to 1, and A greater than B is also the 0. So only one is high, one of these outputs. Depending upon the result of comparison, if A is less than, in the output side there is a three comparisons are there, three outputs. In that three outputs, one of these output only the high. Okay, let us see, go for the 1-bit comparator. The comparator, 1-bit comparator. The comparator having the two inputs A and B, having n number of inputs for A and the B also, and outputs are 3, A equal to B, A less than B, A greater than B. Okay. Now you can see the 2-bit comparator. For the 2-bit comparator, A having A0 and A1, B having B0 and the B1. The first of all, if I am taking that, if A1 is equal to 1, B1 is equal to 0, means the A1 bit is high and B1 bit is a low. Okay, so A is greater than B. If these two bits are equal, A1 and B1 are equal, then we compare the A0 and the B0. A0 and B0. So this is A0 and the B0. You can see the A0 is equal to 1 and the B0 is equal to 0. So you also see that the A0 is greater than the B0. So using these two, we are writing it one expression, the Boolean expression. So A greater than B means A is 1 uncomplement value, B1 is a 0 complement value, A1 B bar plus R means R otherwise. If these two are equal, you can use that exclusive NOR A1 exclusive NOR B1. Then comparing the another two bits A0 and the B0 bar. A0 is uncomplemented 1 value and B0 bar is a 0. So A is greater than B. The similar way, for to get it is a less than, whatever the equation we got for the A greater than B, the bar is for A1. A1 bar B plus A1 exclusive NOR B1, A0 bar B0, because A value is less than the B value. So see here, if B1 is a 1, A1 is a 0, B1 is 1 and A1 is a 0, then it is a less than, A less than B, R means nothing but is a plus. If B1 and A1 are equal, B1 and A1 are equal means A1 exclusive NOR B1, and we are using the AND here, AND means product, and B0 is equal to 1, A0 is equal to 0. A0 is 0 means A0 bar, B0 is equal to 1 means B0. So put it, these are total as in the equation, A less than B, A1 bar, let us see here, comparing the A greater than and the A less than B, A1 bar B1 plus A1 exclusive NOR B1 and A0 bar B0. Okay, the first expression is A greater than B, and second expression is A less than B. Following my students. Then the third comparison equal to. So here also we are comparing the A1 and B1 first of all. If those two are equal, and if A0 and B0 are equal, then A equal to B. So equality condition is exclusive NOR operation, A1 exclusive NOR B1 and A0 exclusive of B0. We are not taking the R condition here. When you go for the R, if it is not equal, it is not the greater than. If these two are equal, then we are going to the another bits, comparing which is greater than and which is the less than. If both are equal, you can use that there is a AND. A1, B1 and A0 and B0. Both are equal. Both we are using the exclusive OR operation, exclusive NOR operation. Now, You see the A greater than B, the first equation. A greater than B is A1 B1 bar plus A1 exclusive NOR B1 into and A0 B0 bar. So A1 B1 bar, one indicate is here, and A0 B0 bar, A0 B0 bar, another indicate. And third input is also used here. That third input is A1 exclusive NOR B1. A1 exclusive NOR. See here, A1 B1 exclusive NOR is connected the second AND gate input, and these two is outputs is connected to the NOR gate to get the A greater than B. Following my distance. Then equal condition, you can see the equal condition A1 exclusive NOR into A0 exclusive NOR B0. So outputs of two exclusive OR gates by taking off A1 B1 and by taking off A0 B0, we get A1 exclusive NOR B1, A0 exclusive NOR B0 is connected to the AND gate because it is a product. To get the output is A equal to B. Coming to the less than, A less than B. A value is complement and the B value is uncomplement. Less than means complement for A. Greater than means complement for B. So A0 bar and the B0 and A1 bar and the B1. The third input of the first AND gate here for the less than, it is from A1 exclusive OR of B1. When we are comparing these two, A1 and B1, if it is a less than, directly get it is a less than only. Otherwise, if this is equal, then we are going for the A0 and the B0. So A0 bar and the B0 we are comparing by getting of the second equation to get A less than B. Following is totally the inside of the block diagram, logical diagram, whatever we design now. This is the inside of this IC having A0, B0 and also A1, B1. Outputs are the same, A equal to B, A less than B and A greater than B. Following my distance. Then you go for the 4-bit comparator. The 4-bit means A having the 4 bits and the B also having the 4 bits. So first of all, if I take that A3 and B3, if A3 is 1 and the B3 is 0, then A greater than B. Or if these two are equal, A3 and B3 is equal, A3, B3 is equal, then we are comparing A2, B2. A2, B2. A2 is 1 and the B2 is 0. Okay. If these two are also equal, or means it is a plus, or A3 and B3 are equal, and A2 and B2 are equal, and if A1, B1, A1 is a 1 and the B1 is a 0, or plus, if all these three inputs, all the 3 bits, A3, B3, A2, B2, BA1, B1 is all, it is equal, and finally if A3, B3 are equal, and if A2 or B2 are equal, and if A1, B1 are equal, and if A0 is equal to 1 and the B0 is equal to 0. Every time you can compare from the MSB bit to the LSB bit, A3 is greater than B3, directly by taking that equation only, we can say the total equation A with having 4 bits and B having the 4 bits is a greater than. Otherwise, if these two are equal, we go for R, A3 and B3 are equal, if A2 is equal to 1 and the B2 is equal to 0. Or if these A2, B2 is also equal, or A3, B3 is equal and A2, B2 are equal, and if A1 is equal to 1 and A0, B1 is equal to 0. Okay. The total theory, you can put it in the Boolean expression. See here, A3 is uncomplementary value means it is a greater than. A is greater than. A3, B3 bar plus, if these two are equal, you can write it as in the exclusive NOR operation, A3 exclusive NOR B3, then A2, B2 bar. R plus. If this is also equal, A2, B2 is also equal, then you go for the comparing of A1, B1. So to write that equation as in the third term, A3, B3 equal, A2, B2 are equal, and A1, B1 bar. And if this A1, B1 is also equal, A1, B1 is also equal, then you go for the last bit, LSB bit, comparing of A0 and the B0 bar. Okay, but the Boolean expression is are A3 B3 equal, A2 B2 equal, A1 B1 equal, and A naught B naught bar. A naught B naught bar. The same expression for the A less than B also. What is the difference here? Keep the A bits is bar and B bits are uncomplement value. You see, A3 bar and the B3, if these two are equal, A3 exclusive of B3, A2 bar B2 plus A3 B3 equal, A2 B2 equal, and A1 bar B1 is a complement and the uncomplement of B1 plus A3 B3 equal, A2 B2 equal, and A1 B1 equal, and the last bit we are taking as a comparison, A naught bar B naught. Same, both the equations are the same, but when A is greater than B, A bits are uncomplement value. If A is less than B, A bits are complement values. Equal to means all the 4 bits are equal. A3 B3 and A2 B2 and A1 B1 and A naught B naught. Whatever the last expression is there, the last term in the A greater than and the A less than, the A naught B naught is also equal. A naught and B naught is also equal. That you can take it as A equal to B. Now, by using these 3 Boolean expressions, you can draw the logical diagram. You see here, I'm using A3 B3 one exclusive OR gate, A2 B2 one exclusive OR gate, A1 B1 one exclusive OR gate, and A naught B naught as one exclusive OR gate. This is equal condition. Okay, all these outputs is connected to as input of OR gate. We'll get A equal to B. Otherwise, A greater than B. You can see the first AND gate. It takes A3 B3 bar. Okay. In this stage only, if it is a A3 is greater than, if it is not equal, directly it shows A greater than B. If these two are equal, you see this is a line. If these two are equal, one of the input of the second AND gate, that is the A3 and the B3. And another bits we are taking A2 and the B2 bar. A2 and B2 bar. At this stage, if it is A2 is greater than the B2, we can stop the without comparing of A1 and the B1, B naught, A1, B1 and the A naught, B naught. If these two are also equal, then the third AND gate having the 4 inputs will get. That 4 inputs is one input is from A3, B3 is equal, and another input is A2, B2. A2, B2. Follow my students, A2, B2. Then, if in this stage, at this stage, third stage, A1, B1 is equal, greater than B value, we can stop for comparing of A naught and the B naught. Otherwise, or if A1, B1 is also equal, A1, B1 also equal, then we are going for go for the comparing of the last bit. That comparison of the last bit, A naught and B naught bar. And for the last AND gates, you can see it having the 5 inputs. The first 2 inputs are A3, B3, second input is A2, B2, and the third input is A1, B1, and another 2 inputs are the A naught and the B naught bar. Okay, A naught and the B naught bar. So to get it is A greater than B. The same logic diagram, but only the change is A naught bar B naught, A3 bar and B3, A2 bar and B2, A1 bar and B1, A naught bar and the B naught. The complement for the A. To get the less than, to get the greater than, complement is for B values. See the first AND gate having only the A3 and the B3. So A3 bar and the B3, and second AND gate is if A3 and the B3 is equal. You see, he connected directly from the A3 and the B3. Comparing of A2 bar and the B2, it is a less than value. If A2 and B2 is also equal, then we compare the A1 and B1. So the first 2 inputs of the third AND gate is A3, B3 and A2, B2. Now we are comparing A1 and B1. If this A1, B1 is also equal, then you go for the last AND gate. 3 inputs, A3, B3, A2, B2, A1, B1, and A naught bar and the B naught. All these outputs is connected to OR gate to get A less than B. A less than B. This is a total logic diagram. It is inside the block diagram what we have. Is a block diagram with the inputs A and B, not A naught and B naught, with the inputs A and B, A having 4 bits and B having 4 bits. That is from A3 to A naught and B3 to B naught. The outputs is the same, A greater than B, A equal to B, A less than B. Okay, so we completed the designing of 1-bit comparator, 2-bit comparator and the 4-bit comparator. In a similar way, you can also design the 3-bit comparator also. A having the 3-bit and the B having the 3 bits only. Okay, there is no any, whatever we have here, the 4-bit is there. There is no any A3, B3. Only it is A naught, B naught, A1, B1 and A2, B2. No need of the A3 and the B3. You can remove that A3 and the B3, it is a 3-bit comparator only. If you can increase A4, B4 also, it is 5-bit comparator and so on. Like that you can design the comparator. Like my dear students, I hope you can understood all of you. And the next one is a priority encoder. It's a priority encoder. We already know what is an encoder means. Encoder is a reverse operation of the decoder. What is a decoder? N number of inputs and 2 power n number of outputs. N number of inputs and 2 power n number of outputs. Okay, so if it is a n is a 2, 2 square is output. So 2 by 4 decoder, 3 by 8 decoder, 4 by 16 decoder and so on. 5 by 32 decoder like that. What is the encoder? Is a reverse operation. A reverse means the inputs are the outputs and outputs are the inputs of the decoder and encoder. In the encoder, 2 power n number of inputs, 2 power n number of inputs and n number of outputs. 2 power n number of inputs and n number of outputs. So what you can call it as here, 4 by 2 encoder. Because of 4 inputs and the 2 outputs. 8 by 3 encoder. And 16 by 4 encoder, 32 by 5 encoder. Now in that, the priority encoders, we already know the encoders. Now you can go for the priority encoder, so priority bits. Okay, priority. It is possible that 2 or more inputs are active at a time. 2 or more inputs are active at a time. To overcome this, priority encoders are used. You see how if it is only the one input is active, if there is any 2 or more inputs are active at a time, to overcome this priority encoder is used. How it is, you can see. A priority encoder is a logic circuit that responds to just one input is in accordance with the some priority system among all those that may be simultaneously high. The most common priority system is based on the relative magnitudes of the inputs. Magnitudes of the inputs. In some practical applications, you can see here, in some practical applications, priority encoders may have several inputs that are routinely high at the same time. And the principal function of the encoder in those cases is to select the input with the highest priority, to which you have to give the highest priority. And you see, we can take the 4-bit priority encoder, the 4-bit priority encoder. The 4-bit priority encoder, in addition to the outputs A and B, the circuit has a third output also we are taking. Third output. So why it is encoder is nothing but 2 power n number of inputs and n number of outputs. What is the 2 power n here? The D0 to D3 is 4 inputs are there and 2 outputs. So encoder means priority encoder. For this priority encoder, I am additionally taking the another input, that is a V. the 4-bit priority encoder in addition to the outputs of A and B. We have to 4 inputs means you can take only the 2 outputs for as of encoder. But priority encoder, additionally we can add 1/3 input, third output as a V. This is a valid bit indicator that is set to 1 when 1 or more inputs are equal to 1. When this value is 1 means when the inputs, you see again, this is a valid point here, this is a valid bit indicator that is set to 1, that is set to 1. See here, all the values is 1, 1. That is set to 1 when 1 or more inputs, 1 or more inputs are equal to 1. Okay. If all the inputs are zeros, there is no valid input. So see here the D3, D2, D1, D0 is all the zeros. The V value is a 0 here. When the D0 is a 1, D0 is a 1, the AB values is a 0, 0. D1 is a 1, the AB values is a 0, 1. D2 is 1, the output is 1, 0. D3 is a 1 and output is 1, 1. Simply it is a decoder. When I am taking the 0, 0, D0 is a high. 0, 1, the decimal value is a 1, D1 is a high. 1, 0, the decimal value is a 2, D2 is a high. And the remaining all it is a zeros actually. Remaining all the values is a 0. And 1 or more number of inputs. So 1 or more number of inputs, it is a 1. If all the inputs are the 0, there is a no valid input. If E is equal to 0, the other 2 inputs are not inspected when V equals to 0 and are specified as a don't care condition. See, 1 or more, and why I represented here the don't care, and here also the don't care, because whatever the inputs is there is a 0, 0, what is a 0, 1, 1, 0, irrespective of this one. If all the inputs is a 0, the V is also the 0. When the V is equal to 1, when 1 or more number of inputs is a 1, then the valid input, valid bit in the output side, whatever we represented in the designing, is the value is 1, 1. Okay, for 0, 0, 1, it is a 1. And now the D0, I take it is a don't care. Means either it is a 0 or 1. Means 1 or more inputs is a 1 here. And here also you can see the 1, 0, the D2 is a high. In the D1 and the D0 is represented in the don't case. Don't care means we can't say it is a 0, we can't say it is a 1. Again, the input side, there is a 1 or more inputs. Similarly, there is a don't case is there. Okay. And that don't case, we can represent it, we can use that as a 0, or we can also use the 1. So valid point, valid input, valid bit indicator that is set to 1 when 1 or more inputs are equal to the 1. If all the inputs are the 0, there is no valid input and V is equal to the 0. This is a truth table to get. Now what is a V is equal to now? The V is equal to where it is a high, D0, and where it is a high, D1, and the V is a high at the D2, and V is high at the D3. So D0 or D1 or D2 or D3. Okay. So according to that, the truth table outputs of A and B are A is equal to the min terms, if it's a 1, 2, 3, 4, 5, 6, and up to so on 15, and the B is equal to 1, 2, 1, 3, 4, 5, 7, 9, 11, 12, and 15. Using this, you can use the K map. Why they can take the min terms 1, 2? You see here, this is a 0 value, and this value is 1, and from here it is 2, 3, and so on. And B is equal to 1, 3, and then it is a 4, 5, 7 like that. It's whatever the midterms you can take. It is a wrong, my dear students. See, by using this only, we can get it is a 4 bits are there here. 4 bits. In this 4 bits, we can't say this is a value. The don't care condition it is. Don't care condition means it is a 1, 1, 1, 0 is also there, and 1, 0, 1, 0 is also there. Depends upon that, it is a changes the combinations of don't cares. The combinations of the don't cares is changes. Like the don't care is we can keep it as a 0 and 1. 0, 1, 0, 0 is a one time. We'll get 1, 1, 0, 0. We'll get the another time. And similarly at the 1, 0, 0, 1, 0. 0, 0, 1, 0 is a 1. And 0, 0, 1, 0 is a 2. And similarly 1, 0. 1, 0, 1, 1, 0 is another value, and 1, 1, 1, 0 is another value. Okay, and totally the 15 inputs are there. 15 means 0, 0, start from the 0, 0 to the end, the value is 15, 1, 1, 1. Okay, and taking that min terms, this is not the min terms, my dear students. According to this, here the min terms, keeping off 0, 0, 0, 0, 0, 1, 1, 0, and 1, 1, and here 0, 0, 0, 1, 1, 1, and the change of the values. I will show that also. You see here, we got A value, D0, D1, D2, D3, and AB values, and V is the input. If all the inputs are the zeros, irrespective of the inputs A and B, the valid bit is a 0. And D is 1 and 0, 0, 0, it is a 0, 0. The valid bit is a 1. And it is a don't care, 1, 0, 0, it is a 0, 1. And both are don't cares, 1, 0, that is a 1, 0. And don't cares here, not the don't cares, and this value is 0, not the 0, it is a 1, 1, 1, 1. Okay. Now you can see the valid bit is a 1, 1. So to get the V is equal to, that is D0 or D1 or D2 or D3. That is one of the output. The additional output we added as a V valid bit. Now I am taking the A also. What is the A min terms? Min terms where it is a high. Where it is a high. These 2 bits only it is a high. See, let us see the values is don't care 1, 0. 2 don't cares. 2 don't cares means that is a 0, 0, 0, 1, 1, 0, and 1, 1 option is there. That is a 1, 0, 1, 0, 1, 0, and 1, 0. So these are the options. Similarly, and the don't case, 3 don't case of 1. 3 don't case of 1. 3 don't case means that it is a 0, 0, 1, and that is a 0, 0, 1, 1. That is a 0, 1, 0 of 1, and 0, 1, 1 of 1, 1, 0, 0 of 1, and 1, 0, 1 of 1, and 1, 1, 0 of 1, and 1, 1. Okay, these are don't case. These are options we have. Now you can see that the values. What is the value of this one? The 2 is a 6, and this one is a 7, and this one is a 30, 12, and the 4, 12 and 2, 14. 14, and this value is 1, and this value is a 3, and this value is a 5, and this value is a 7. Okay, my dear students, and this value is a 9. This value is a 9, and this value is 11, and this value is a 13, and the 15. So now these are the minterms. These are the minterms for the A. Okay. So how we got the don't case? I am taking the options 0, 0, 0, 1, 1, 0, 1, 1. And here 3 don't case are there. See what are the minterms, and now the A is equal to the minterms are here. The 1 is there. 1, 2, 3, 5, 6, 7. 7 2 times are there. You can write. It is not the 7, my dear students. It is a 1, 0, 1, 0 is a 10. 1, 0, 1, 0 is a 10. So 7 is there. No 8, 9, 10 also we got 11, 13, and the 14 and 15. So these are the minterms. To get it is a E. 1, 2, 3, 5, 6, 7. See whatever in the material is right or wrong. 1, 2, 3, 5, 6, 7. Okay. 1, 2, 3, 5, 6, 7, 9, 10, 11, 9, 10, 11, 9, 10, 11, 13, 14, and 15. 13, 14, and 15. Okay, whatever we are having, it is also right, my dear students. It is not the wrong. So similar way, the B also. You see the B here. B, to get it is a B. Don't care 1, 0, 0. So here the 1, whatever the don't case we got here, the same thing. So 0, 1, 0, 0. Another thing is 1, 1, 0, 0. Okay. So what is this value? This is a 4 and this is a 12. So 2, 6, 10, 14 is not there. Only 1, 3, 4 for the B is equal to. If I write here, B is equal to the minterms are 4, 1, 3, 4, 5, 7, because these are the same. Whatever these are 1 here and 1 here, these are values whatever the same. 1, 3, 5, 1, 3, 4 is also there. 5, 7, 9, 11, 13, 11, 12 is also there, because here we got the 12, 12, 13 and 15, 13 and 15. So these are the minterms 1, 3, 4, 5, 7. See whether it is right or wrong. 1, 3, 4, 5, 7, 9, 11, 12, 13, 15. 9, 11, 12, 13, 15. 9, 11, 12, 13, and 15. Okay. Like that, we'll got the minterms. Means whatever the options are there, they don't case the highest priority. We are giving that for 1 or more number of inputs. By using these minterms, we go for the K-map. See whatever in the material is right. In the K-map, you can see 1, 2, 3, 5, 6, 7, 9, 10, 11, 13, 14. You can say these are 2 8-box combinations. 1, 2, 3, 5, 6, 7, 9, 10, 11, 13, and 15. 2 8-box combinations. For this 8-box combination, see, for this 8-box combination, we'll get D3, and for this 8-box combination, D2. Okay, D2 is high and D3 is changes of 1 to 0. A will get. And similarly, the B is A 1, 4, 1, 3, 5, 7, 1, 3, 4, 5, 7, 9, 7, 9, 11, 12, 13, and 15. So 1 8-box combination and 1 4-box combination. 1 8-box combination, whatever we got here, also the same. D3 plus for this 4-box combination, D2 bar and the D1. D2 bar and the D1. So D3 changes from 1 to 0 and D0 is changes from 1 to 0 to 1. So we'll get the D2 bar and the D1. So using these A and the B equations, you can draw a logical diagram to get A, B, and also the B. And also the B. The B is output. When there is a high, if there is any input is one or more number of inputs is high, the V value is a valid input and it is the value is set to the 1. If all the inputs are the 0, the value of valid output valid bit is a 0 value. The designing of inside the designing of the priority encoder with the 4 inputs D3, D2, D1 and the D0. Actually, as an encoder, it is a 2 power n number of inputs, n number of inputs, outputs only, and there is a valid bit we are taking in the output side, that is a V. D3, D2, D1 and the D0. Why I wrote here the A means A is the D3 and D2. D3 and D2 is represented A and D1 and the D0. Logical diagram for 4-bit priority encoder. If you can take it is a 2-bit priority encoder also. 2-bit priority encoder 0001 like that. So let us see that also. I will show. The 2-bit priority encoder means D0, D1. D0 and the D1. If both are zeros, A value is don't care. Because why I am taking the A, it is a 2 inputs only. Okay. And if it is a 0, the value is 1 and the 0. And don't care, the value is 1. It's not the 0 here. The 0 only, it's a 1. When D0 value is there, D0. And 1 value is there, D1 is a high. The valid output is a 0 and this value is 1 and this value is 1. So V is equal to D0 plus D1 and A is equal to what are the min terms you get? Because it is a don't care 1, 0, 1, 1, 1, 0, 1, 0, 1 is a 1, 3. Following. Like that we'll get the same whatever in the 4-bit comparator, not the 4-bit comparator. That is a 4-input priority encoder. 4-input priority encoder. Only the 2 I am taking. That is a D0. So don't care of 1. You see the A is 0 for D0 is high. If A is 1 now, it is A is 1. You'll get don't care. It is a 1. D1. Can increase anything. Either A is 0 or 1. If it is A is 2 bits means AB 0, 0, 0, 1, 1, 0 and 1, 1. 0, 0 is a D0 is high and 1, 0, 1 is a D1 is high. But here A is 0, D0 is high. A is 1, D1 is high. And at that time, with a priority encoder, D0 is a don't care. You can take it as a 0 and 1. So you'll get the min terms of 1 and 3. Using the 2 variable K map, you can find out the Boolean expression of A. We already have the V is equal to, and you can draw the logical diagram.